Hi, I'm YongSik and I've been working for LG CNS over 20 years as a system engineer and architect. LG CNS is Korea's largest IT service company that has expertise and capabilities acquired from over 30 years and hundreds of large-scale IT projects in Korea and internationally. In recent 3 years, I've been in charge of Perfect Twin, which I'm gonna introduce to you as a new testing approach to ensure a successful go live of a newly developed IT system or services. Let's get started. In Korea, normal large-scale system implementation projects like next generation banking systems have been doing phased and coverage expanding tests. The few iterations of unit tests, integration tests, system tests, and user acceptance tests. Even after these costly tests have been performed in several IT projects, critical defects and failures have still been found after go lives due to the unexpected scenarios in cases that was not tested for. Although it depends on the size of the IT project, the testing and deployment phase accounted for an average of 45% of hours spent in IT projects of size 4,000 man-months or greater. This raises the questions: how many and what kind of tests are required to make new system defect-free? How can you answer yes to, can the new system run without failures after go live? Traditional testing methods have three fundamental limitations. An advanced understanding of the business is required to create realistic testing scenarios. However, even with considerable business knowledge and experiences, it is nearly impossible to create all the scenarios and cases which can occur in a real situation, because it is necessary to define all the business conditions as well as the inputs and expected result values. Once tested scenarios and cases and data are prepared, IT project members, such as developers, designers, business leaders, and customers, execute tests, record defects, and debug repeatedly. As the test coverage expands, it becomes difficult to test the entire related service repeatedly whenever there is a modification to the new system due to limited time and budget. In the traditional testing method, when the functional tests are almost completed, a performance test is executed by executing a part of a scenario using Roadrunner, JMeter, or similar tool. But what if some services that for the performance test have a serious performance bottlenecks? And how can you tell if the performance of the new system or services are improved as compared with the older system or services? Traditional testing methods use several ways to check whether the test results are correct or not. For example, test results can be checked by querying the data stored in the database or by following the business flow on the screen. Both validation methods consume additional manpower and don't even ensure accuracy. Most IT projects can be categorized into four types: SI, SM, cloud migration, and infrastructure replacement. Upper figure shows how many legacy business services typically remain under the new system for each type of IT project. New system usually includes most of the most of the legacy services unchanged or partly changed in terms of business functionality. Even in the case of next generation systems, the proportion of new services that never existed is at most 30%. Therefore, it is crucial to test or validate before go live with whether the legacy business services that remain in the new system run correctly as per reproducing the functionality and performance of the old system. In order for us to be confident that existing business works well without errors, we have to validate if the existing business operates stably in a situation similar to the actual environment. Perfect Twin validates the new system's functionality and performance as compared to the old system. Perfect Twin automatically reproduces the actual transactions of the current system, which are generated by actual users, devices, or external systems in the new system in real time or batch mode, and compares the response messages of the new and the current system. For example, at the moment, a user reserves a movie ticket on the reservation screen of the current system. The same reservation transaction is reproduced in the new system. The both processing results are instantly and automatically compared to determine whether the function and performance of the new system are correct. That is, if the current system is the production system, which has usually a huge number of concurrent users, devices, and external interfaces, we can test or validate the new system in a realistic environment before go live, eliminating potential defects and ensuring the quality of the new system. Perfect Twin use a mechanism similar to that of service virtualization in respect to having an outbound external interface, but it differs from the service virtualization in that Perfect Twin reproduces real-time inbound and outbound transactions and automatically supports flows of transactions in a new system. In addition, service virtualization is intended to emulate a dependent system or service, not a service under test, whereas Perfect Twin aims to automatically validate a system or service under test based on real live transactions. For example, let's assume that a user reserves a movie ticket with the reservation number 100 using the old reservation application, which sends a request for an available seat to an external system and receives an available seat 3A. If a tester reserves a movie ticket using the newly developed reservation application, the new system can send the request for the available seat to the actual external system. With perfecting, things can be changed. Perfect Twin first captures and stores the old FPP transaction message into simulator and reproduce the user transaction in the new reservation application. The new reservation application sends a request for an available seat to the simulator and receives available seat 3A, which is the same as the old FPP transaction message, and the user receives a response message with the reservation number 91 this time because the reservation number is generated using a database sequence. In this situation, if the user cancels the previous reservation, the request message includes the reservation number 100, but this reservation number is not valid in the new system, and Perfect Twin automatically changes the reservation number from 100 to 91, which is valid. In order to do this, Perfect Twin manages and changes session and service key information automatically. In real environment, a large number of users and external systems make transactions, and by reproducing these transactions, Perfect Twin can validate the new application in a situation similar to the actual environment. With Perfect Twin, there is no need to define business scenarios at all. This is because all the transactions that occur in all the system become the test scenarios and cases for the new system. Since all legacy business transactions are automatically tested on the new system with real data, it is possible to validate against all the real business cases that are encountered within the test period. As a result, almost all potential defects can be found and eliminated. Unlike manual testing method, Perfect Twin can perform regression tests automatically. In K-Life case, 80 millions of transactions were tested or validated with 260,000 unique transactions over 40 days. Perfect Twin as an alternative performance testing solution. Perfect Twin compares the response times of the older system transaction and the new system's reproduced transaction. Therefore, it's possible to immediately check the performance of the new system in terms of the entire service as compared with the older system. Accurate information is obtained with respect to where further tuning is needed, and performance bottlenecks can be eliminated more effectively. With respect to test results evaluation, Perfect Twin can detect any slight differences in the response messages, such as a 1 cent difference, and will automatically log the test result as failure. Perfect Twin can visually show the validated transactions or services, the failed services, and the performance degraded services. K-Life Insurance, the third largest life insurance corporation in Korea, has been a successful customer use case that achieved a 100% of match rate between the old and the new insurance proposal details, such as insurance premiums, cancellation refunds, and guarantees. The new system was different from the old in terms of UI, transaction message structures, insurance product structures, and product code schemes. Perfect Twin was applied about for 1 year in real time. That is, at the moment a life planner executed a transaction, The same transaction for the new system was reproduced automatically in the new system. Daily transaction volume per day was nearly 2 million. N-Card is one of the top 5 card corporations in Korea, handling about 10 million card approved transactions per day. Perfect Twin was applied to the N-Card Next Generation project and used for real transaction tests in batch mode in the branch test phase, which followed the integration in system test phase. For the first result, Perfect Twin reported that less than 1/5 of daily transactions was reproduced due to various performance issues, and only 93% of reproduced transactions succeeded in the new system. This meant that there are over 700,000 transaction failures, and go live will be a disaster. Within a month, N-Card achieved a greater than 99% success rate. N-Card actively utilized Perfect Twin by validating against over 100 million real transactions and rapidly identifying the functional and performance defects that needed to be fixed. As corporation operates a building and resort management construction business, the biggest concern was how to ensure the migrated system on AWS cloud will perform as fast as the legacy system. This was a difficult problem because existing performance test products could not handle the entire new system service and compare with the older system service response time. This problem was addressed by applying Perfect Twin. Perfect Twin captured and reproduced the entire set of all the system transactions in the new cloud environment in real time and compared the response times of both transactions. It was simple to check which service showed the performance degradation and needed further tuning. It was also possible to optimize the cloud configuration by easily recognizing how much impact the EC2 instance and other components specification changes had on the system performance. The total volume of captured and reproduced transactions in real time was over 400,000 over about 40 days. The new system showed the same performance as measured by Perfect Twin after go live. In the case of infrastructure replacement projects, it should be ensured that entire applications have no defects, even if the applications have no changes. Manual testing of thousands of application services requires significant manpower. The case securities infrastructure replacement project included a DBMS upgrade as well as hardware replacement. Perfecting was applied in log file capture and reproduced real transactions in batch mode. They could found that duplicated 28 SQL queries that could not be run on the upgraded version of DBMS and over 200 DBIO modules that required performance tuning. The total number of captured and reproduced transactions was over 300,000 over about 30 days. Thank you very much for listening. For more information, please contact perfecttune@lgcns.com.